Okay, class, let's start. Okay, so we will look at the second order DE for today. Okay, so we have got 4 questions in total here. So let's look at the first one. So first one, we are already given the second order DE, and also given that we have got all the values x equals to 0, and also dx dt equals to 2 and t equals to 0. So find x in terms of t. So for this one, the first part we know we are going to solve this second order DE. So to solve the second order DE, we'll actually start with the auxiliary equation. So from the auxiliary equation, we will find the roots for this auxiliary equation. And from this auxiliary equation, we know we can actually form the complementary solution. So one thing that we have to be that we have to take note is that when we form the complementary solution, make sure we use the correct variable. So in this case, the independent variable is t, the dependent variable is x. So our complementary solution to this equation will be x with a subscript c to indicate that is our complementary solution. So with the two roots that we have here, so this would be the complementary solution that we have. Okay, so that would be for the complementary solution. As for the particular solution, okay, because we have got right hand side is 2 times e power negative t. So for the particular solution, okay, we will just make the xp, which is our particular solution, to be e to the power of a negative t with a constant which is unknown. So let's say we put an a to it. Okay, so a is our constant which is unknown. We are going to solve this. So before we can solve this a, we need to differentiate for the xp. We will get x prime p and also the x double prime p. Okay, so after this, okay, we substitute all this particular solution back into the equation again. Okay, so we just add all the terms that we have here, and then we will actually end up with the a here is equals to 1. Okay, so with this a is equals to 1, okay, we can actually find out what is our particular solution already. So a particular solution is just this one, e to the power negative t. And with that, okay, we'll actually get the complete solution. Okay, the general solution, which consists of the complementary solution and particular solution for this case. Okay, so there will be this expression. Okay, always remember when we will only substitute values in to solve all those constants after we have got the general solution. So we don't use it on the complementary or the particular alone. We will use it, okay, when we have the solution which we have combined the complementary and the particular together. Okay, so by using this, where we combine the complementary and particular by using the values that is given earlier, t equals 0, x equals to 0, we will actually have one equation which consists of the C1 and C2. Another equation that we need to solve from there is we are given that we have got dx dt. Okay, so in order for us to get the dx dt from the general solution that we have for this one, okay, we will have to differentiate it lah. Okay, so after we differentiate it, this is what we get. And do the substitution accordingly. When t equals to 0, dx dt is equals to 2. So from there we substitute and solve. Okay, in this case we will have my C2 here is a 0. So the C2 here is the coefficient of the e power negative 2t is a 0. So from there we actually get our value for another constant. Okay, so with that, just substitute all the constant back into the equation again, and this is the result that we will actually get. Okay, so basically that's for the first part of the question. So second part of the question, it says the solution to part A is used to represent the motion of a particle P on the x-axis. At time t second, okay, where t is greater than 0, P is x meter from the origin O. Show that there is a maximum distance between O and P is this value, and justify this is a maximum distance. So when we talk about the maximum or minimum distance, we it's very automatically that we relate the dx dt equals to 0. Okay, so in this case, we already have the value, rather the expression for x in terms of t, so we can actually find our dx dt easily. So provided that we have already got the x earlier on, so this would be our dx dt. Okay, so basically next what we need to do is we need to solve for dx dt is equal to 0. Work with the exponent term, and we will actually have the t is equal to half ln 3, or if you want, we can actually write that as a ln of root 3. Okay, so this is the t when we have the maximum or the minimum. So we will actually have to substitute this t back into the equation of the x and evaluate the values. Work with them carefully. We have got 3 ln root 3, and then also we have got the ln root 3 here. So just have to work with those things carefully, okay, and then we should be able to get the values that is given in the question. Okay, so we have already proven this. So next one, okay, we are supposed to prove that, okay, this is the maximum. So when we want to prove maximum or minimum, we need to use the second derivative, which is d squared t dt squared here. So our d squared t dt squared, you have two choices. Okay, you can actually differentiate from here to get the x double prime. You can work from here, or if you don't want to risk, okay, and you might, okay, get some error from there, okay, if you don't want to risk it, you can actually look at the original equation. So in our original equation, we have already all this, okay, we already know what is the dx dt. The dx dt here is just a 0 because that is when the maximum or the minimum point happen, and we know what is the value of the x. The value of the x is this one. When we have the t is the value of the t that we have found just now when we have the dx dt is equal to 0. Okay, so if we substitute those values inside the first equation, the very first equation here, okay, and if we do the calculation from there, we can actually prove that the second derivative of the x here is a negative value. So what does that mean? If it is a negative value for the second derivative, it means that value for the x is a maximum value. Okay, so we can actually have two ways to actually do that. Okay, so that is for our first question. Second question. Second question is first is to find the value of the lambda for which y is equal to lambda x sine 5x is a particular integral of the differential equation, which is given in this form. So for this one, in the first part of the question, they already gives us the particular integral. So what is meant by particular integral in this case is the yp that we usually have is a particular solution to the equation. So we will have to work with that one first. So when they talk about this particular integral, so it means this y, okay, will actually satisfy the equation as well. So in our equation, we have got d squared y. So we have to differentiate this. Okay, this is our particular solution. We have to differentiate this 2 times. Okay, and it's not difficult to differentiate as long as we apply the product rule carefully. And next is just substitute all this, okay, the y prime and y double prime into the equation given again. Okay, so this is what we have, and from there we will actually end up with this equation, which we will actually have the lambda here is a 3/10 or 0.3. Okay, so in that case, because our right hand side we only have the cos 5x, okay, at our right hand side. So in that case, right, the left hand side, the x, there shouldn't be any x cos x, or if there is, the coefficient will be 0, and for that one there is no x sine 5x here because you see there's nothing here. So this is why the x sine 5x will actually get cancelled off here. So at last we will only have this nice term, okay, the lambda, the 10 lambda cos 5x to compare with the 3 cos 5x at the right hand side. Okay, they should usually they should cancel off nicely one. Okay, so this is what we have for the lambda in the first part. We already have got the yp. Okay, so part B, okay, using your answer to part A, find the general solution to this DE. So now is to find the general solution. Before this, we have got the yp already, so we need to find the yc now. So to find the yc in this case, okay, we solve the auxiliary equation. So in this case, we have got the complex roots, okay, which we have got plus minus 5i in this case. So that will actually gives us the yc is in this form. So finally, okay, our general solution, which consists of the yc and the yp, just add them together. Okay, so part B is just This one, no? Okay. So for the last part, okay, the part C is about they give us the values and we are supposed to find the particular solution to this differential equation. So basically is to find out what are the values for our C1 and C2 from the values given. So for that one, once we have got the correct solution in part B, it shouldn't be any issue when we actually find this one. So again, this is our general solution. Sub in the values when we have y equals to 0, x equals to 0. It is good that we have got C2 is 0. So our y is only this one, and we only need to find C1 in this case. So in order for us to use another set of the value, we need to differentiate. That's why we get a y prime here. Differentiate this carefully. Okay, and from there we sub in the values when x equals to 0, the dy dx is equals to 5. So with that we get our C1 is a 1. Okay, so at last we will actually get this solution. Okay, so that would be for our second question. Okay, third one. So for third one is quite a usual question, I would say. So this is the differential equation given, okay, to describe the motion of a particle along the x-axis. First part is to solve, is to find the general solution to this differential equation. Basically is to follow all the steps that we usually do. Okay, first is to look at the auxiliary. So for this auxiliary equation, there is only one root. So we have the root for this auxiliary equation is -3. So just when we actually form the complementary solution, our xc is e power -3t with another one is t times e power -3t. Okay, so always have to be careful of the variables that we are working with. It's x and t. Okay, not the y and x. Okay, it's x and t in this case. So in this case, the solution will be x in terms of t lah. Okay, so that completes the solution for our complementary, our xc. So xp, the particular solution is to look at the right hand side of the equation. So if we look at the right hand side of the equation, again we have got like something which is in terms of the cos or sine. So it's cos 3t. So whenever we have got cos 3t or sine 3t or both of them together, no matter how is it, okay, we must always include the sine as well. Okay, no matter it's just sine or it's just cos or both of them, we always have to include both sine and cos as well. Okay, this is a rule in solving. So our xp is just letting a sine 3t or b plus b cos 3t in this case. And in order for us to substitute, okay, we need to differentiate 2 more times to get the first and the second derivative. And next on, okay, is to substitute this 3, okay, back into the equation again. Okay, for the second derivative, first derivative, and also the x in this case. Okay, so from there, okay, we will have to tidy up all the a's and b's lah. Okay, and this is the last thing that we will actually get for the a's and b's. So the good news is we do not have anything which involves the sign in this case. Okay, we will only have a solution which is in terms of the cos in this case. Okay, so in this case, our value for the a in this case is 1/18. So in this case, our xp is 1/18 sine 3t. Okay, so you can see like although the particular solution is a sine 3t, but at last, okay, what is satisfied is the equation that has a cos 3t. Okay, so it's very important for us to make sure that our solution must contain both a sine and cos. Okay, so just combine them together for the xp and the xc. So this is the value that we the expression for x that we should get lah. Okay, so of course after that is to find the solution, okay, the particular solution, okay, when we are given the values where we have t equals to 0, our x is half, and the x prime is 0. So by using the first set of the value, okay, t equals to 0, x equals to half, it helps us in finding the c1, which is equals to half in this case. And the next one is we need to differentiate this one time to get the x prime. In order for us to apply another set of the value, which is x0, x prime is also 0, which actually gives us the C2 is a 4/3. Okay, so in that case, we can actually get this solution for the x in terms of t. Okay, so this is quite a typical questions lah. Okay, so next one. Okay, so find the value of lambda for which lambda t squared e power 3t is the particular of this differential equation. So for this one, we have to work with the, in this case, the yp first. So we have got the yp is given by this one. And in order for us to substitute into the equation, we need to differentiate 2 times to get the y prime and the y double prime. Okay, so just have to work with that carefully because we have got to use the product rule. So be careful when we actually work with product rule when we have like so many terms here. Okay, so later on is to substitute this, okay, into the equation because this is the equation given earlier on. So substitute all of them nicely. Okay, so this, when we actually add up these 3, we will actually have the right hand side is given as the equation. So solve for the lambda in that case. The lambda is a 3. Okay, so that will be the first part to solve for the lambda for our particular integral. And part B, hence find the general solution to this differential equation. So it's just looking at the auxiliary. So the auxiliary equation in this case is a repeated root. So the root here is 3. So it will actually gives us the complementary y is e power 3t plus t times e power 3t in this case. Okay, so of course at last we need to state the general solution. Okay, is to add the yc and the yp together. Okay, so that will be our general solution for the y. Okay, lastly we have the values given where we have t equals to 0, y equals to 5, and the y prime is equals to 4. So just substitute those sets of values inside. First is to use the t0 and y5. So from there we will actually get the c1 very easily. And as for the y prime, okay, to use the y prime and the t, okay, we need to differentiate, okay, this y into the expression that we have for the y prime. Okay, so differentiate that carefully because again we need to use quite a bit of the product rule and substitute the values in, and then we will actually get the value for another constant. So at last just state, okay, what is the value for our constant at last. Okay, so that will be our part C. Okay, so okay, last one. So last one involves a little bit of the transformation of the equation into a simpler one. Okay, so the substitution given here is y is equals to xd. Okay, which we have to transform this equation into another equation. So okay, what we have is we have y is equals to xv, and we are supposed to change, okay, in this, if we compare these two equations here, what happened is we are changing all the y to the v. Okay, so how do we actually achieve that is we need to find, because we are supposed to replace the d squared y dx squared and the dy dx to get something which is in terms of dv dx, something like that. So the easiest way to start with is we just find the dy dx for this one, because later we can actually substitute and replace, okay, those dy dx and d squared y. So starting with the y is equals to xv, okay, for this one. So we find the dy dx. So basically dy dx is just we differentiate the xv with respect to x. So this one has to use the product rule, keep the x, differentiate the v, and this one is keep the v and differentiate the x. Okay, second derivative is when we differentiate this whole thing again, no? So for the first term here is this one is keep the x, we differentiate the dv dx. This one is we keep the dv dx and we differentiate the x. Last term here is to differentiate the v, so we get dv dx. So we can actually add up the 2 dv dx here to get 2 dv dx. So this will be our expression for d squared y dx squared. So next thing is we don't really have to do a lot of manipulation for those like the result that we have here. There's not a lot of things that we can do. So we the easiest way is we just have to substitute all those things that we have here, okay, inside the equation. So given that this is the equation that we have, we just sub in the things. Okay, so make sure that we eliminate all the y from there in order for us to get v and x only. Okay, so if we actually expand out all the terms, okay, and we can actually do cancelling, we will actually end up with something nice in this case. So something even nicer is we can actually cancel off the x cubed for both sides, so which will actually result in a very nice equation. Okay, so that is the proof for part A. Okay, part B. So part B is to solve this differential equation, okay, to find v as a function of x. So this is our equation, okay, that we're supposed to solve. So start with auxiliary equation, which we will end up with complex root in this case. So the complex root gives us this, okay, c1 sine 2x and c2 cos 2x. So remember, because now we are solving for v in terms of x, so the variable here must be clear, okay, don't mix up with the y, okay. So that would be our complementary. So looking at the right hand side is a linear, okay, it's an x. So if it is a linear, when we actually do our particular solution, the vp in this case, we must include the linear term, which is ax plus b. Okay, so remember, not just ax, it's ax plus b, because why it is linear? Because this x here is a linear term, so we have to include the whole linear term, which is ax plus b, and from there differentiate, okay, one time the v prime and the v prime p. Yes, Dennis. Is a 4, yeah. So we have got 4r squared plus 4 is equals to, thank you for the correction. So this one we will get an I, okay, so we only get sine x and cos x. Okay, so for that, okay, we will actually proceed with the yp. Okay, yp is still like this. And then if we substitute all these yp, okay, into the equation, then we should be able to get the values for the a and the b in this case. Okay, so in this case, the yp here is a 1 over 4x. So at last, just combine all the solutions that we have. We have got v is equals to c1 sine x plus c2 cos x plus 1 over 4x. Okay, and that would be the solution, which is v in terms of x. And at last, okay, what the question one is, the question one's the solution, which we have the general solution for the differential equation 1. So that one means we have to find the value, not the value, sorry, the expression of y in terms of x. Because we know that the y is equals to vx, right? So we just have to use this v to multiply by x. Okay, so all the 2's are not there lah. So basically that would be our solution for the y, okay, in terms of x. Okay, so that is it for the second order, and this would be the last session that I will have with you all. So all the best in exam, and if you need any help, if you need to ask question, you can always WhatsApp me, okay, for this few weeks. Okay, all right, so thank you everyone.